Hey guys, I wanted to give you a quick overview of mirrors and lenses, because these are topics that tend to show up both on the SAT Physics subject test and on the AP Physics 2 curriculum. They were also in I believe, the AP Physics B curriculum, but now the College Board has split that course into two parts. They now fall under the AP Physics 2 curriculum. Okay, so what is a mirror? And this is just a brief overview. I'm sure that there are videos and things that you could find online that go into much greater explanation with the visuals, but this is just a sort of textual overview of the difference between mirrors and lenses and also the different types of mirrors and lenses. So a mirror is an optical device that forms an image from an object by reflecting beams of light. And there are two types of mirrors. So one is the concave mirror. So if you had a point here, and then you had a mirror that curves in toward the center, this would be considered a concave mirror. And then the opposite of that would be if you had a mirror that curves outward from the center over here, that would be a convex mirror. Okay, so there's basically four important things to consider whenever you talk about a mirror or a lens. So number one is going to be, is the focal length positive or negative? Okay, so for a concave mirror, this is kind of trivial. The focal length, which would be from the center halfway along the radius of curvature, so this would be the focal length, we consider the focal length positive for concave mirrors. Here it would be the opposite. So here you have the center, right? And then if you were to imagine reflecting the center over the mirror, then this would be the center here. And then if you were to go to the left, your focal length would be sort of inward toward the mirror on the opposite side. So the focal length would be this over here. So since it's going to the left and not the right over here, it's just a mathematical convention. We would consider the focal length to be negative. Okay, for a concave mirror, the image is on the same side. The image is on the same side. So you can imagine that if I had, I don't know, a beam of light going like this, and then it would reflect over here through the focal point because that is a paraxial ray. It's parallel to the radius of curvature. And then if I had another beam of light that was going like this, and it would go bounce off this way, then the point of intersection of the two reflected beams of light would be the image. So the image would be facing downward here. This would be the object here. So we see actually two things. We see that the image is on the same side as the object, and also the image is inverted. So the image is inverted. In other words, the image is oriented the opposite way as the object. So as you can imagine, the exact opposite is true for the convex mirror. So for a convex mirror, the image would be formed on this side because you would have beams of light reflecting on this side, which would converge over here to form an image, converge over here and intersect to form an image. So you can imagine that the image is now on the opposite side for a convex mirror. Image is on opposite side, and the image is upright. Also, we need to consider, is the image real or is the image virtual? So remember that an image is real if there are beams of light shining on the image, which is actually the case for a concave mirror. See, the image is here. The object is here. So the image is here. So there are beams of light that are actually shining on the image because it's on the same side as the object. So the image for a concave mirror is real. Image is real. The opposite is true for a convex mirror. For a convex mirror, the image is virtual. Virtual means that there are no rays of light shining on the image. Okay, so this is the sort of overview of mirrors. Okay, now we're going to be talking about lenses. So a lens, you can imagine that if a mirror is an optical device that forms an image by reflecting light, then a lens is an optical device that forms an image by refracting light. refracting light, not reflecting it. So there are two types of lenses. One is a converging lens. A converging lens is oriented like this. It is called biconvex because it is made of two convex mirrors. You could think of it as basically two convex mirrors that converge into one another. So it's one on the left, one on the right. So you have sort of a device that's curving inward to itself. And then you have a diverging lens, which is called biconcave because there are two concave components. So there's one that's concave outward here. There's another one that's concave outward here. So you put them together, you have a diverging lens. You could see that this one, the converging lens sort of closes into itself, and then the diverging lens sort of opens outward on itself. Okay, so a converging lens, the focal length we consider positive. The focal length would be something like right here. For a diverging lens, however, the focal length is negative. So you can imagine that the focal length is something right here. Okay, for a converging lens, the image is on the opposite side. So this is different from what I talked about with mirrors. So when I talked about a concave mirror, I said that the image is on the same side. Well, because a lens refracts light rather than reflecting it, that means that the incident rays would be refracted on the opposite side. So when those two rays intersect, then the image would be on the opposite side, not the same side that the object is on. It's the exact opposite for a diverging lens, however. That functions the opposite way. So for a diverging lens, the image is on the same side. Also, for a converging lens, the image is real. Okay? Because if you have a beam of light shining here, that's refracted over here, and the image is also on this side, then you would have beams of light shining on the image. So the image is real. It's the opposite for a diverging lens. For here, the image is virtual because the light would be shining away from the generated image. Also, the last thing that we need to consider is for a converging lens, the image is inverted. So for a converging lens, the image is on the opposite side. So the image would be over here. It's real, but it's inverted. So the image would be here. And then it's the exact opposite for a diverging lens. So the image for a diverging lens is upright. The image is on the same side as the object. It is virtual because there's no light shining on it, but it's upright because the beams of light would converge over here. Okay, so that was an overview of mirrors and lenses. Now let's talk about the two equations that you need to know. Okay, so there's one called the magnification equation, which tells you that the magnification of the image is equal to the opposite of the distance of the image from the mirror divided by the distance of the object from the mirror, which kind of makes sense because if you consider the focal length to be negative, for instance, as would be the case for a convex mirror or a diverging lens, then you would also have the distance of the image from the mirror being negative. So thus a negative times a negative divided by a positive, because you always consider the length of the object from the mirror positive, would give you a positive magnification, which would mean that the image would be upright. It would, as you could probably imagine, function the exact opposite way for concave mirrors or converging lenses, because the focal length would be positive, and thus the distance of the image from the mirror would also be positive. So you would have a negative value divided by a positive value, because the distance of the object from the mirror would always be positive, which would have a negative magnification, and thus the image would be inverted. And then there's one other equivalency that you need to know, which is that it relates the distance that the object is from the mirror as well as the distance that the image is from the mirror to the focal length of the mirror or the lens, which is that, so the reciprocal of the distance of the object from the mirror plus the reciprocal of the distance of the image from the mirror is equal to 1 divided by the focal length. And also for magnification, as you might imagine, the height of the image is directly proportional to the height of the object. So that is that the height of the image is equal to the absolute value of the magnification times the height of the object, because the magnification could be either positive or negative, but the height must be always positive. I hope this helped, and I will see you in the next one.